Oh, of course. Let's all use 4 threads. Okay, to make sure that we all use the same number. So let's go with 4 threads. So the first loop takes 1 second. So while you're working on the loop 2 and 3, or maybe 3, let's do the first one together for those who would like. Okay. So I'm going to parallelize this. Okay. Which schedule did you use? Which one? Oh, for loop 1, for loop 2, for 3. Auto, done. Go back home. That can work. Let's try to see. So that's totally a valid answer. Let's try to see if we can come with a crafted one for this. Anyone who did not use auto, the whole room. No, just auto. Guided? Okay. Who else tried guided? Okay. Who used static? Okay. Dynamic? Oh, you're waiting for. Okay. Okay. Well, everybody used auto. There's like 2/3 of the room didn't raise their hands. So it's like, no, just auto. Okay. Well, try to understand the costs of iterations. That's what you'll need to do in your actual scientific codes. Every iteration is going to wait for a certain amount of time that is constant. I'm using this wait for crafted function to simulate some workload, okay? To keep the thread busy for a given iteration, to make iteration X, in this case, taking a certain number of milliseconds, okay? Every iteration takes the same amount of time. So we don't have the problem of having iterations whose weight goes up. So guided, we don't need that now. We're fine. If we remove guided and not jump on auto just yet, between static and dynamic, both can do a good job. So if you want to use dynamic, let's try. It didn't help. Can someone tell me why I didn't get an improvement and why I never will see an improvement here? Just for that simple loop, right? I have just 5 lines of code, and I came back with my super fancy dynamic or schedule something, and improvement of the parallelization, none. I said, what, sorry? Oh, you mean giving a chunk size explicitly? I can try that. Let me try that right away. Maybe the chunk size, indeed. Any other idea? It was worth trying. No, even more fundamental than this. Passing a variable was the second topic we've seen. What was the first one? The very first thing we've seen in OpenMP. Yeah, David? Yes, we're just running with one thread right now. We asked OpenMP, every time you see parallel, you spawn 4 threads. But this for loop is not parallelized. We said, okay, use an OpenMP 4, so when I have all my threads, tell them to split the work and everything. But I don't have the threads. I'm not inside a parallel region. The parallel here ends there. So all my red line, all my red arrows are gone by now. So I need to recreate them. So I can use a parallel here. Okay. So let's get back to the original starting point where I've not even given a schedule, and let's see how that works. Oh, 3.3 times faster. Interesting. Because what happens is now it does a static by default. So it already does some type of things behind the scenes. Okay, so now if you want, we can try something else. So we can try dynamic. Okay, let's try dynamic. Schedule. Ah. It was just to check you would spot it. I never know, people can believe it. Okay. Didn't help. The gains of having this dynamic load balancing is outweighed by the weight of the actual monitoring behind the scenes. So, or, yeah, okay. Okay, that's a good starting point. Max 4 threads, 2.5, we got 3. That's actually interesting. Yeah, makes sense. Okay. Second, what did you use for the second? Auto! Who didn't use auto? At least someone. Yeah? Yeah, David, yeah. So yeah, that's when you start to see something that looks like triangular, something minus I and so on. Yeah, guided is a good reflex to have. But so instead of taking 5.5 seconds, it takes 5.3 seconds. Oh no, 1.5, okay. 1.5 up. And if we were to not use guided, just to paralyze it, just to paralyze the loop without any explicit scheduling, what happens? Just for fun. $2.7, okay. The thing with this, and I'll finish with this one quickly now because I'm overrunning, so. I love to be sneaky every now and then. So what I did was guided create chunks that are lighter and lighter, okay? So that works really well when the iteration cost starts from very low and goes bigger and bigger. What I did was to design a for loop where iterations get super small, super big first, and become smaller and smaller and smaller. So what you did if you use guided was you created a super massive chunk for the first thread, a big chunk that contained all the biggest iteration, and then you told thread 1, here you go. And the final thread received a tiny chunk made of tiny iterations. So it was the worst thing possible. But the solution is equally sneaky, that's why I love it. Instead of, so the cost of the iteration does this, right? And we like when it does that. So then, instead of iterating this way, I'm simply going to iterate that way. And then the cost is going to do that again, and my guided works perfectly. So instead of starting at 0, I'll just start at max -1. And I'll stop at 0. And then I can use my guided. Then, of course, we have so few iterations here that maybe it won't actually make a difference. So I'm going to try, but maybe it won't actually even make a difference. Yeah, 1.8. On larger iteration sets, because you will see that in real-world programs, your loops tend to have more than 10 iterations, then it will make a difference. Okay, the final one. What did you use for the final one? That's where I was expecting to hear Auto, because that's the way to go in this case. It's hard to determine, yet it's too bad. First Auto, second Auto, and the third one, which was Auto, silence. Because this one, you're going to wait a certain amount of time times a random number. By definition, you cannot predict this one, excluding the type where you know the random number generator or something. So since you cannot tell in advance what's going to happen, Auto is a great one, because you can tell the compiler, do some fancy stuff. It will probably be helpful. So you delay that to the compiler. Okay, well, so that was the final exercise. So now if we are to summarize, if I don't get the right window, it's not going to work. Yeah. If we are to summarize, we've seen already a certain number of topics today. Trust me when I say there's a lot more. So some of you might have been bored because it was too easy. Some of you might be like, oh, I'll need the evening or tomorrow to finish understanding this, because clearly there are quite a few concepts that I still cannot grab. That's fine. Just know that there's a lot more for you to discover. Task-based parallelism, collapsing loops, tiling loops, especially powerful for GPUs. Hyper-threading, that's when it comes to hardware as well, the placement. False sharing, my favorite trap. Asynchrony, and a lot more. You can go to the OpenMP forum website to check it. Now, as always, with every single workshop I ever run, regardless of where I run it, there's a whole survey available, okay? To give you an idea, sorry, where do I have my, here, okay, fine. Don't worry, I'm going to give you more time if you need the QR code, so you can go there, okay? I take it the QR code has been scanned. Because you may wonder, yeah, but it's just feedback, basically, you'll never do anything about it. Well, look at the little number in the bottom left corner. It's the code again? Okay. It says what, sorry? Ah, okay, sorry. Okay, got it. Fine, well then let's do this one directly. I'll take directly this one here. Display, so that was the live one. Okay, fine. It's the participant one. That's going to be trickier. Okay, that escapes me, but okay. So when it's live, it's the questionnaire, but live I can do live. Okay, fine. So you see that now? Yes? Is it what you see now? Okay, perfect. Great. So yeah, if you look at the slide in the bottom left corner, you have this version. Why? Because all my workshops go through multiple versions based on what? Feedback. The version you've seen today is not the version I've taught at Pawsey last December, which was not the version I taught in Ireland 2 months prior, which is not the version I taught in Edinburgh 2 months prior. I keep integrating and iterating all that feedback, okay? So if you want to make your version 1.4 better, tell me what was not good here so I can change it. Tell me what you think was good here so I can keep it. And hopefully, we just improve everything all the time. If you want to have a look concretely, if you go in my events, you can see or when it loads, of course, if it wants to load. It does not want to load. Okay, it's fine, I already have that here in case. So you can see all the surveys. So you can see the survey for that workshop, HPCSS 24. You can see it when I was in POSE. That's the one that's the version in POSE. That's the version at QB in Ireland. That's the version from HPCSS last year. So it's every time there's there, okay? So we'll see how your feedback compares, if all of a sudden it has become terrible, or if it's okay. Where are we up to so far? Does it have? Okay, great. Oh, nice. Oh, what, 31? Okay, well, you're quick. Okay, you're quick. Okay, great. Well, then I guess thank you all for this. 10 minutes extra. Okay, you'll forgive me, hopefully. So thank you for your time. That was the CPU part. Tomorrow we dive on the GPU part, which I guess will be new to most of you. If you have feedback, again, all this is anonymous anyway. As I always say, positive and negative equally welcome, right? So feel free, and if you have any questions, come to see me. Otherwise, time to get a well-deserved break before the poster session tonight. Thank you.